got all the stretching and stuff out of the way? Okay, just want to make sure. Okay, so my name is Theron Stanford. I'm from the Los Angeles area. I've been working on Perl corporately for the last 8 years, and Perl in general for the last 16 years. And I'm moving to the Isle of Jersey, and so I'm kind of looking for work. So if anyone has any ideas, I'm more than happy to entertain them. So, since I'm from Los Angeles, that means I'm from near Hollywood, magic capital of the world. So I brought a magic trick. So, here is my folder. I have to prove there's nothing on my sleeves, right? Or else it's not a magic trick, alright? So you see short sleeves. You'll see that in this directory, there's only one file. There's one Perl module, index array. Okay? So we will use the most simplest repo that we can, and go from there. Let's see. Does that need to come up a bit? Or? Oh, you can see.
We can see it. Okay.
All right. So I'll make sure. Okay, so first we use our module. All right, so index array. Well, that means we need an array and we need index. So we will do index array, and we'll have an array. Alright, so this array is empty, so let's put something in the array. Alright, to prove that I filled the array, what is this index? Have I touched the hash index? It doesn't look like it. But suppose I do something like this, and you want to know, oh wait, where in the array was the word Pascal? Was it first? Was it second? Well, we have an index. So we'll print index Python 1. So that means there must be element 1 in the array. Index Pascal. And second, and to prove that we're right, we can print the array again. So standard enough. Python was element 1 and Pascal was element 2. Alright, well, let's do something more fun. Let's sort the array. So that array equals sort array. So what should be, where should Pascal be then?
Zero.
It should be 0. Well, let's see it there. All right, print index Pascal. It's 0. All right. And Perl, let's see what Perl is. It's 1. Now, obviously, Perl should not be anywhere but the beginning of the array, right? Well, we can fix that. So we'll just say that the index of Perl has to be 0. Print that array. And there you go. Perl is back where it belongs. All right? And, oh, we can push things on. So let's say push at array. Oops, that didn't. Let's see. Try this again. PHP, there we go. Alright, let's see if that works. PHP is there. All right. Maybe you hate prolog. All right. Well, we should put prolog at the end of the list. Easy. Index. Prolog. What's the end of the list? -1, right? So. I got prolog again. Okay? Now, suppose we have an interloper. Splice that array 2, 0, Ruby. Alright? It's obvious why it's an interloper, it doesn't deal with people. Alright? It has nothing to do with language. It's just, if we're poopy, it'd be fine, but it's not poopy. Alright, so print that array. And you can see Ruby is where we expect it to be. Now, before we added Ruby, we know that prolog was 0, 1, 2, 3, 4. It was in position 4, right? But now prolog is in position 5. Can we verify that? Yes. Right? Index. Prolog. Okay, so we know it's in 5 instead of 4. Okay? Well, we don't really want Ruby to be there. So let's get rid of it. So that array. So 2, 0. Oh,
-1.
I did something wrong.
One element.
What? Please?
Splice that array to 1.
To 1, that's right. That's right. Thank you. That's right. Exactly what it should be. Alright. Splice that array to, because we have to get rid of one element. Exactly. Alright, so print that array. And it's gone. And we want to print the index of prolog. It's back to 4. Okay? Well, Ruby is pretty persnickety. So, what we're going to do is we're going to say $index of Ruby. Well, we'll do this first. Suppose we say index of Ruby is 3. So for print the array, there it is. Ruby's popped up in spot 3. Alright, well we don't want it there, alright? So we gotta get rid of Ruby. So splice at array 3, 1, print at array. That's gone. Alright. Ruby still wants to be in there. So we do $index Ruby equals 4 times rand. no, wait. Equals, what's the notes? Rand. We don't have anything. No, we can do, okay, int, that's right. We need to do int, rand, and we got 0, 1, 2, 3, 4. Okay, 4. Alright? So is it in there? Oh, not only did it take a random spot, it decided to take the beginning, alright? But, okay, suppose we don't know where it went though, because it's randomly put somewhere, right? Well, it's in the index. Why don't we just delete Ruby, right? Oh, it's gone, see? So you didn't have to know where the index is. All you know is Ruby's in there somewhere, and I'll get rid of it. Alright. So, that's the magic trick. The question is, how did it be magic? Alright, this is where tie comes in. The purpose of tie is what? It's to make scalars and arrays and hashes and a few other things, file handle work. Make them act like you think they're supposed to act. So, if you want to assign a value to a scalar, you do it. Or if you want to splice an array or change an element array or whatever, you can do it. But tie has the ability so that when we do this, it can do other magic things behind the scenes. So let's see how this is done. Alright, so what was the first thing I did? I had to use the module indexed array and tell it that the array at array and the index percent index were to be tied together so that the index hash was the index for the array. Okay, so we've got here it is, package index array. Use strict, use warnings. Okay, they've got this great new feature in Perl. I don't remember which, if it came in 18 or 20 or wherever, okay? But they've got this new feature now where when you had a reference to an array, like $array, then to dereference it and turn it to a real array, you put the @ in front. But then the problem is things would get all these nested arrays of hashes of arrays, and you have to remember, well, you got to go to the right sometimes, then I have to put an @ in the front, and I forget to put the curly braces, and it just gets confusing. So they have this new way so that you just always have to go from left to right. So if I want my array reference to be dereferenced, instead of putting the @ in front, I can take my reference and use the arrow, because we always use arrows for dereferencing, and then use @ and star, or @ and asterisk. And this is actually the same as if you took the @ and put it in front and put the curly braces around the $0. Okay? So, I like that so much that I don't know if there's a petition or whatever, but hopefully they keep this thing. But since I'm using that feature, I have to put that in the code. Use feature post deref. And since it's experimental, every time I use it, Perl says, "Oh, you're using something experimental." And so I have to take a turn of warning off, so it'll start hassling me. Okay?
Don't you just say use experimental post deref?
What was that?
In core knowledge, one experimental, yeah.
Oh,
You
okay.
say use experimental post deref.
Oh, okay.
And it's no longer experimental in read. It's the warning's going to go away in 5.4.
As I just told you, I've been a Perl developer for 8 years, and I've been a Perl developer on 5.8.8 for 8 years. So a lot of these other things I'm not as good at. Okay, I can learn. I can proceed. I can learn. But yeah, so I might not have all the syntax perfectly done, but I know how to get it to work. Okay. So when we initialized, we wanted to initialize @ array and percent index. And so what we need to do is, if we just send that over to a subroutine, everybody knows lists, arrays, and hashes will just get flattened. So we have to use a prototype to say, leave the array alone, leave the index alone, and send a reference to the array, and send a reference to the index. And then when we do that, then we know that we're going to get, we know we're going to get a reference to the array, reference to the index, and then we can use tie. Now, we use @array and percent index, but behind the scenes, those guys didn't do jack. Okay, they just represented something else. Behind the scenes, we had another list that has a $A, a $I, and a $P. I'm not going to talk about $P for a while, so you don't think that. The $A is the real array, and $I is the real hash, or reference to the array, or reference to the hash. And so when we tie them, you can see that @array and percent index use the same behind the scenes references, so that when I muck with @array, I can change $A and $I at the same time. So that when I look at the index, it's already taken care of. And same if I do something to the index, then it's already taken care of for @array. Alright, so what is tie? Tie says that, so we're tying an array to a package called indexed array array. So that means the package indexed array array has to be able to do everything that you want to do to an array. You want to be able to set a value, you want to be able to look at the value, you want to be able to do splice, you want to be able to do push, unpop, whatever. But what happens is, with the tie, when I typed in, for example, when I typed in print at array, what it really did was it said, okay, go to this thing, $A, $I, $P, and then there's a subroutine down here. I'll show you, don't worry, I'm not hiding anything. That says how to get the elements out of $A and return them. So, let's scroll down. So here's the next array. So tie array. Anytime you do a tie, you have to use either tie array or tie hash or tie scalar to make sure it's tied. And so basically, it would just say, with less at array into index array. So here's fetch. So when I try to get an element out of the array, at array, it would call fetch. And fetch says what? So fetch would look up the $A, and then the other arguments to fetch would be which element in the array you want. 0, number 1, number 2, whatever, okay? So it's just like any other kind of lookup, we just send it in a subroutine. So we pick it up, take it, and we know it's really $A, so we return it. So you have fetch, you have store. Store is a little trickier. When we store something, we have to put it in the array. We also have to make sure that the index receives where it is in the array. Okay? Someday I'll put this on GitHub and you can all look it up. I don't think it's really important to understand in detail what's going on. The gist is, by using the store subroutine, I can look at the back end array reference and hash reference and manipulate it. Okay? And so we got store, fetch, side. Arrays are particularly hard to implement because you have all these things you have to worry about. You have push, and pop, and splice, and shift, and unshift. They all have to be done separately. You can't just do one and then they all fix. Okay? And splicing in particular is difficult because if you take it out, if you take elements out in the middle, then all the elements after that, all their indices change by 1. You have to go to the hash and change everything. So this probably wouldn't be too good in a highly efficient production system, but it's still kind of fun to play with and learn about how tie and how tie works. Okay? Is that clear? Now clear you have to be very careful with. Okay? Notice I couldn't just wipe out my object because the tie had that reference. If I just wiped it out, I'd lose all my connections. And so I have to go in specifically and say, clear the first thing, clear the second one, and clear the third one. Otherwise, all the references get broken, and then my magic goes away. All right. So then we have a similar thing for index, where you tie the hash, and then you want to know where prolog is. It'll tell the value will be prolog. It says where prolog are you? And it'll say, first or second or whatever. Store is the same. Store is usually the most difficult one to implement, at least in this magic, because you have to keep worrying about the indices moving back and forth. And then delete's also a little tricky because if you pull it out, then you have to change all the indices for things around it. So you have to ask yourself, well, what did I delete? Where was it? So that I can change the other indices. Okay? And then, of course, with a hash, you have to be able to return the keys one at a time. But this is easy because the keys are just the elements in the array, right? So that's what the $P represents. When we're doing an each or something like that, where we're getting the keys one at a time, then the $P records how far along we are in the array returning these keys. And so, you don't even have to look at the hash, because we know that the values, we know that the keys of the hash are exactly the elements of the array. So when we want the first element of the hash, we just return the zeros element of the array. And then when we want the next one, we increase that $P to 1 and return that. And then we increase it, and eventually when there are too many, or gone to the end, then we return nothing. We return undefined, of course. So
Don't
it's
need to
okay.
do it that way. You don't need to separate your $P counter, because the next key gets passed an argument of the previous key. So you could take that argument, look it up in your hash, get the index of the previous one, and then just increment that in turn.
There's always room for version 0.02. Alright. Let's stay right there. Alright. Any questions? Alright, I think have I used my time? Oh, question, yes.
Is it on CPAN?
No, it's not on CPAN. This is just something I've been kind of playing around with. I looked on CPAN to see if there's anything like it. You know, so I looked in list util and all those and couldn't find it. And so that's always a scary thing about CPAN, right? You create this one more thing, you show it, and someone says, oh, but that's in the Acme thing, or that's over here. So no, it's not on CPAN yet. But you think this is worth it? I haven't. I'm not a pause author yet, so maybe this is my chance. So
Yes.
let's put it on. All right. All right then. Okay. But no, tie is, it's not always the right solution, but tie can be very useful. For example, to give another quick demo, we had where I worked, we had logs, and our logs were awful. And the reason our logs were awful is what they would do is they would just take a whole bunch of name-value pairs and cram them in a log, in a text file. And then we'd store them as Pascal strings, which means you'd say the length of the string and the string, the length of the string and the string, the length of the string and the string. And of course, it was also bad because sometimes the string would be more than 256 characters. And so you couldn't just use one byte to represent the length of the string. And so you had to, and it was really, in fact, I can show you, in fact, it's worse than that. All right? But basically, it was this pattern like this. All right? So what this means is the A picks up all the characters, but then the W figures out how many characters you're packing and puts that number in front of your strings. So they have a really easy way to pack these Pascal strings. Alright? So it's really fast. But everyone knows pack is pretty fast. It's when you try to unpack what's very difficult. Alright? And so let's see, if I go to pack parser, I created a log file that was 828 megabytes. All right, and it's just all these logs over and over and over again. All right, how do you parse that? Nobody wants to try reading it and using unpack to do that. Or I tried that once, but it took too long. And so what I did is I wrote an access module to parse it. And so let's see, of course, the access module has to have a PM to go along with it. Pack parser, okay? So I read in the module, and then what I do is I initialize the log, and I have this variable called bars, and I can send it a callback. So every time I look at this thing, I just run the callback on the bars. And the reason I do this is that in our logs, typically you log a lot of stuff, but you don't want to know a lot of stuff. Okay? And so if I went to unpack and unpack all this thing into a hash and found out I only needed 2 variables, I'd be done. And so instead, what I do is I take my log and I mmap it. And so instead of storing, so my key is the name of the variable, but my value is a pointer to the file where that variable is, which is a lot faster to store. So then I don't need it until I want it. And then that's where tie comes in again. I can use tie so that when I want that variable, it'll look and go, oh, that's where the pointer is. Go get the real value and bring it back. And then I can use tie. So it's what copy on read. So then I don't have to spend all my time putting all this thing into files. I mean, we would have files that would take 45 minutes, log files that take 45 minutes to parse the old way, because they have to take all this time to break it out and put it in the hash and run it. And so when I wrote this, it got done in about 5 minutes. Okay, so the combination of tie and the using the XS was a great success. Okay, are there any questions? Well, that's the entertainment for me. I mean, obviously the next week will be very, much more entertaining. But yes?
Not in general about your nice indexed array.
Yes.
Could you quickly show me how you ran your live demo, what you used to...
Are you talking about this rebel?
Oh yeah, the rebel. Yeah.
All right.
It's a one-liner.
It wasn't a rebel, it's a rel, because it doesn't print.
That's right, that's true. So it's a rebel, yes.
It's just a very
But it's right there. So,
There.
so I just, just leave the standard in every time. Just send something and evaluate the
I'll just have myself just a second.
So that was to prove that I had no other tricks up my sleeve. I mean,
Well, yeah, the first thing you did was to load a module file, and that didn't do anything.
that's right.
To the 4K.
That's the hidden sleeve.
You can't be a good magician without a few good cracks.
That's right.
He's using a computer.
Should have renamed the module hat.
So anyway, tie's not always a solution, but sometimes it can be useful. It takes a little extra work to set up. But once you get it set up, and you get all the syntax taken care of, then you can just write code like crazy, and then not worry about it.
It's painfully slow.
Well, that's what I mean. It can be painfully slow, but like I just said, when I replaced our unpacker with my XS, we went from 45 minutes to 5 minutes. So you have to be judicious in it. I mean, you're right, it is slow because it's got all that magic going on in the runtime, the core runtime, to have to look things up. So, but it can be the solution. So it's important to understand all these things about Perl because you never know what might be the solution. Okay? Anything else?